So what is this stuff called polypropylene? Let's break it down. Science is cool. Polypropylene, or PP for short, is a type of plastic. But it's not just any plastic, it's one of the most common and versatile plastics on the planet. Think of it as a super strong chain made of tiny repeating building blocks called propylene monomers. It's a thermoplastic, which means you can melt it, mold it into a shape, let it cool, and then do it all over again. This makes it incredibly useful for manufacturing all sorts of things we use every single day, from the container holding your yogurt to the bumper on a car. It's lightweight, it's tough, and it's everywhere. Now, not all polypropylene is created equal. Science gives us options. How do we get from a simple gas to a sturdy plastic chair? It all starts with a process called polymerization. That's a big word, but the idea is simple. We begin with our basic building block, the propylene monomer, which is derived from petroleum or natural gas. Imagine a massive box full of individual paper clips right now. They aren't very useful, but if you start linking them together into a long chain, you create something much stronger and more useful. That's exactly what polymerization does, but on a molecular level with propylene molecules. The magic happens inside a giant, high-tech reaction vessel. We take our propylene gas and put it under just the right amount of pressure and heat. Then, we add a very special ingredient called a catalyst. A catalyst is like a super enthusiastic coach for molecules. It gets the propylene monomers excited and helps them link up hand in hand to form incredibly long chains called polymers. Once these long polymer chains have formed, we have a substance that looks like a fluffy, white powder or small pellets. In the world of plastics, there are a lot of different players, each with its own strengths. First up is polyethylene, or PE. PE is generally softer and more flexible than PP. Key difference: density. PP is one of the least dense commodity plastics. It's very lightweight. It can even float on water. Next, polyvinyl chloride, PVC. PVC is rigid, durable, and has strong fire and chemical resistance. PP advantage: no chlorine, simpler and sometimes better for food and medical uses. PP flexibility and fatigue resistance, the living hinge, something rigid PVC can't match. Polystyrene, or PS, think disposable cups, foam packaging, and clear cups. But PP is much tougher and has a significantly higher melting point. Finally, PET, the plastic used for most water and soda bottles. Clear and great for holding fizz. While PET holds in fizz better, PP shines in resistance to heat and moisture, ideal for hot fill bottles and dishwasher-safe containers. Each plastic has its purpose, but PP's balance of properties makes it a true champion. So we've seen that polypropylene is a scientific superstar, but where does it really show up? Let's look around. In the automotive industry, PP is a game changer. It's used for car bumpers, dashboards, battery cases, and interior trim. Using PP instead of heavier materials helps make cars more fuel efficient. It's also great at absorbing impact, which helps keep you safer on the road. In the home, PP is a major player in packaging, especially for food. It doesn't react with food, so your yogurt, cheese, and butter are kept safe and fresh inside their PP tubs. Many of our durable goods, outdoor furniture, storage bins, appliance casings are made from PP. PP can be spun into fibers for carpets, reusable bags, ropes, and even thermal fabrics that wick moisture. In medicine, PP's ability to be sterilized and remain non-reactive makes it ideal for syringes, vials, specimen containers, and surgical meshes. From cars to kitchens to hospitals, PP quietly solves real-world problems. The next time you grab a container of leftovers or sit on a plastic chair, take a moment to consider the incredible science in your hands. Polypropylene is everywhere, quietly making our world stronger, safer, and more efficient. Follow our channel for more insights into the different types of polymers.